In this video, we are going to review solving systems of equations using the elimination method. So a system of equations just means you have multiple equations with multiple variables, and we are going to be solving both equations at the same time. Remember, your solution is the one point, so the one x and y value that make both equations true. So first thing, to solve using the elimination method, we are trying to eliminate a variable. So first, make sure your variables are lined up. So make sure the x's are stacked on top of each other, the y's are stacked on top of each other, and the equal signs are right on top of each other. They are in this case, so we can go into elimination. So if I look at my equation, remember, to eliminate a variable, you need the same number and different signs. So that is what we are looking for. So if I look at my x's, I have the same number and different signs, one positive, one negative. So the x's are what's going to get eliminated here. So what I'm going to do is just add straight down the column. So negative 4x plus 4x is just a 0, so that cancels out. Then I have negative 2y plus 8y gives me a positive 6y, and then negative 12 minus 24, they're both negative, so I add my numbers together and I get a negative 36. Now I just have to finish solving my new mini equation that I formed. So divide both by 6. We get a negative 6 for our y value. So that's half of our answer. Now we need the x value. So to get my x value, I'm going to plug in my negative 6 into one of my original two equations. It does not matter which one. I normally pick either the one with smaller numbers or the one with fewer negative signs. So I'm going to pick the top one just because the numbers are a little bit smaller, but you can use either one. So I'm going to take my negative 6 and plug it in to the y value. And now I have a regular linear equation that I'm going to solve. So we simplify. Be very careful with your signs on these types of problems. Now I have to move the 12 to the other side. And then last step, divide by that negative 4. So we get a positive 6 for the x value. So for our final answer, we have a positive 6 and a negative 6. So this is the most basic type of elimination problem where you already have the same number and different signs. So for our next two examples, we're going to work with ones that don't have the same number or different signs. So the first one we are going to look at is on the screen. For this one, if I look at my x's, the numbers are different. If I look at the y's, the numbers are the same. Because remember, when there's no number in front, there's an invisible 1. So both of my coefficients with the y's are a 1, but they have the same sign, which is a problem. So what I want to do is change one of the equations so that they have a negative sign with them. So to do that, I'm going to pick one equation and multiply every term in the equation by a negative 1. So I'm going to multiply 3x by 1, the 1y times negative 1, and the negative 5 times negative 1. So I'm going to bring this over here. 8x plus y equals negative 16. That first equation stays exactly the same. My second equation is the one that changes. So I have a positive 3x minus y and a positive 5. So now for my y's, I have the same number and different signs, and I can go ahead and solve using elimination, just like the last one. So I add straight down my columns. My y's cancel. And I get my x value. Now, to get my y value, again, I have to plug it back into one of my original two equations. It does not matter which. I'm going to plug it into the second one, just because it has some smaller numbers to work with. So I have my negative 3x, but instead of writing x, I'm going to fill in my negative 1 plus y equals negative 5, and I'm going to just finish solving this for y. So we end up with a negative 8. Make sure you're writing your final answer as an ordered pair. The x first and then the y. So our answer, our solution to the system is negative 1 and negative 8. So I just want to look at one more case with you guys. or one more problem. So for this one, if I look at my variables, I do not have the same numbers with either ones. So this one I'm going to have to do some manipulation to make the numbers the same. So I'm going to pick the x's because the numbers are a little bit smaller, so they're going to be easier to work with. So I have 4 and 7. I want to make those two have the same. I want to make those two the same. So what I could do, I know if I multiply 7 and 4, I get 28. So what I want to do is change both x values to a 28. So to do that, I'm going to multiply the top one by a 4 and the bottom equation by a 7. Sometimes you can multiply just one equation by something and make the coefficients the same. Other times, like in this case, you will have to multiply both equations. So if I just use 4 and 7, I will have the same numbers, but I will also have the same signs. So I do need to make one of those values negative. I'm going to pick the 4 just because. If you want to pick the 7, go ahead and do that. So I'm going to distribute my negative 4 into my first, into the top equation. So distribute it to every single term. And then do the same thing with the 7. Distribute it to every single term. So these are my two new equations after I distribute. So now that I have my same number and different signs, I'm going to just add them like I did in my very first problem. So my 28 x's cancel each other out. I can add my 32 and 63 and add the negative 36 and negative 154. Divide by 95 and we get y is a negative 2. So from here, remember we have to get two answers, the x and the y. So I'm going to take this, plug it back into one of the original two equations. I'm going to pick, with this one, doesn't really matter which one. I'm going to pick the second one just because. So I have the equation. Instead of writing the y, I'm putting in a negative 2. And then I just need to finish solving this for x. So you can see it's just like solving a normal equation. And once you have your two answers, write your solution out as an ordered pair. So this was your quick review of solving systems using the elimination method. Just remember you have to have your like terms lining up and you have to have the same number but different signs. Okay, that part's really important. Same number, different signs.